terms of sines and cosines when it comes to tangent. So if you are stuck and you end up with tangents and you see sines, try changing those tangents into sine or cosine. You end up doing that quite a bit. So the one strategy that you end up doing a lot to get rid of tangents is changing the sines and cosines. All right? So my first step was using my Pythagorean identity. I changed secant squared minus 1 into tangent squared. Then I used my quotient identity. I changed tangent squared into sine squared over cosine squared. And remember, when you divide fractions, you multiply by the reciprocal. So sine squared over cosine squared times the reciprocal of the denominator is 1 over sine squared. And then you can cross cancel and you're left with 1 over cosine squared. And by your reciprocal identity, you end up with secant squared. Like I said, if you're stuck and you have no idea what to do, try changing everything into sines and cosines. When you see a trig function to the second power and you see a 1, look immediately to those Pythagorean identities and see if you can do anything there. Those tricks are not always going to work, but a lot of times there's some good strategies, a good jumping point. And just remember the relationship of reciprocal functions. Secants and cosine, sine and cosecant, tangent and cotangent, so that you can do reciprocal identity substitutions. Those are the 3 most popular. Now, let's take a look at number 4. Pick your side. What side is more complicated? Left. I see a bunch of trig functions to the second power, but I don't see the ones to go with it, so going right to those Pythagorean identities isn't going to help me. But what you also want to look for is you want to look for factoring. You're going to end up factoring quite a bit. Look at this on the left-hand side. Is there a GCF or a common factor you can factor out? You can factor out a what? Cosine squared. Now you see why, guys, I made sure we went over factoring and you got comfortable seeing those trig functions. So I can factor out a cosine squared, and that's going to leave me with a tangent squared x plus 1. Now, notice what happens after I do my GCF factoring. Now look inside the parentheses. Now I have that trig function to the second power along with a 1. So then go to those Pythagorean identities. Tangent squared plus 1. What is tangent squared plus 1 equal to? Secant squared. So that's your Pythagorean identity. Now, what's the relationship between cosines and secants? They are one of each other. Reciprocals. So it's kind of an eeny, meeny, miny, mo. I know cosines equal to 1 over secant, secants equal to 1 over cosine. It doesn't really matter which reciprocal identity you use. I'm just going to go ahead and change secant squared x into 1 over cosine squared x. And again, that's my reciprocal identity. Remember, cosine squared is actually a fraction over 1. What happens when I multiply cosine squared x over 1 times 1 over cosine squared? That's going to give me a what? 1. And notice that's what I'm trying to get to. I'm done. Look at B. Which side in B is your more complicated side? The left side, because you have sine to the 4th. How could you factor sine to the 4th x minus cosine to the 4th x? Which pattern? There's no GCF, so there's a binomial. There's only 2 ways you can factor binomials. Difference of squares or cubes. Which pattern are we looking at when we deal with sine to the 4th minus cosine to the 4th? Are they squares or cubes? Squares. So I can factor sine to the 4th x minus cosine to the 4th x as a difference of 2 squares. So sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x. And here I just factored. Now look at what you're trying to get to. You're trying to get to sine squared of x minus cosine squared of x. I've got the sine squared minus cosine squared. Hopefully by now you're starting to remember this one. What is sine squared plus cosine squared equal to? Trig function squared, 1. Remember, that's your Pythagorean identity. Sine squared plus cosine squared is equal to 1. So it's going to be just simply sine squared x minus cosine squared x. And that's your Pythagorean identities. Because remember, all of this, by your Pythagorean identity, is equal to 1. Okay. Now, the one thing I need to caution you with these Pythagorean identities, cosine squared x minus 1, it looks a lot like a Pythagorean identity, but your signs are off. So what you have to do is you have to factor out a negative 1 in order to use those Pythagorean identities. So you may have to factor out that negative 1. So watch your signs when it comes to those Pythagorean identities. Make sure your signs match up. If they don't, you've got to yank out a negative 1. And remember, negative cosine squared x plus 1 is equivalent to 1 minus cosine squared. Okay? Yep. We're not there yet. Okay, guys, so you've got